Radiation dose. Research into the consequences of exposure to radiation was carried out by Hal Gray in the 30s. He realized that it was not actually the amount of radiation a person is exposed to that is important, but the amount of radiation that is absorbed by their body. The absorbed dose in joules per kilogram is now measured in grays. So, for example, if an 80 kilogram person is exposed to a power of 20 watts of radiation for 1 minute, and they absorb 15% of that radiation, their absorbed dose in grays would be given by the energy multiplied by the percentage absorbed over the mass of the person. But the energy is given by the power times time, and so we have a power of 20 watts for 60 seconds multiplied by 15% absorbed over the mass of the person of 80 kilograms, giving an absorbed dose of 2.25 grays. It was then realized that some types of radiation are more harmful to the body than others. For example, alpha radiation is far more strongly ionizing than beta or gamma radiation. Also, some parts of the body are more susceptible to damage from radiation than others. Rapidly dividing cells are more vulnerable, meaning the testes and the ovaries would be about 10 times more likely to suffer damage than something like an arm, given the same radiation dose. The type of radiation and the type of tissue exposed are now given quality factors, with a higher factor meaning a higher risk. This allows a dose in grays to be converted into a dose in sieverts. Alpha particles have a quality factor or Q value of 20, neutrons a quality factor of 10, whereas electrons or beta particles and all photons, including gamma rays and X-rays, have a quality factor of just 1. Tissue types are given N values. Bone and skin have an N value of 0.01, whereas the brain or the liver have N values of 0.05. So in the example above, the dose was 2.25 grays. If this was alpha radiation absorbed by the liver, the dose in sieverts would be found from the dose in grays multiplied by the quality factors, which is 2.25 grays times a quality factor of 20 for alpha particles times 0.05 for the liver, giving a dose of 2.2 sieverts, in this case the same as the dose in grays. But if the radiation was gamma and was absorbed by bone, the dose in sieverts would then be given by 2.25 grays times a quality factor of 1 for the gamma radiation and a quality factor or N value of 0.01 for the bone, giving a dose of just 0.0225 sieverts. A person's risk of developing cancer or a genetic defect in their offspring from exposure to radiation depends on many factors, and so any calculations are based on very rough estimates. However, one estimate puts the risk of developing cancer from exposure to radiation at around 3% per sievert. What this means is that if we had 100 people exposed to a dose of 1 sievert, roughly 3 of them would go on to develop cancer through that exposure. The average background dose is around 0.002 sieverts per year. This would mean a dose of 1 sievert over 500 years.